Hello, and welcome to the design phase. Okay, now that we got through the first two phases of the system development lifecycle in regards to the planning, which is pretty much the idea paper, the requirements, and also now coming up with a solution based upon those requirements, the next step will be based upon the solution that was selected by you and your customer. It's now time to design it all, put it all together, paint some pictures of it, make sure it's exactly what people want. I look at this phase as really this that. A picture paints 1,000 words in this case. To sit back and kind of put it all down in paper before we actually start the whole process of development. This way you ensure that you're communicating correctly with your users and that they're seeing exactly what they want to see and they can make any modifications just on these prototypes and databases and so on. Does that make sense? That's what this phase is. It's not a very difficult phase, but it's actually just the phase now to take, like I said, your project and now put it into some type of illustrations and just start designing everything out before we actually start developing. So in the previous, we talked about this before. Design phase is the physical designer will meet the specifications described in the system's requirements document. That's exactly what we're going to try to do. We developed a logical model as the new system. That came from the requirements, logical being stuff kind of written down. Now we're starting to get into the point of now doing the physical design, and then we'll finally do the physical implementation in the development phase. What's this phase include? It can include all kinds of things, but based upon some of the literature we're using in this course, it really kind of goes down to these three pieces: the interface design, the data design, and the system architecture. Designing the interface. So if we look at the interface design is now exactly that. The interface design is very important. Everybody wants a system that is easy to learn. We know that. Okay, designing the interface is very important, easy to learn and use. The user interface describes how the user interacts with the computer system. It consists of the hardware, software, screens, functions, outputs, and features that affect the two-way communication between the user and the computer. So let's look at that one more time. It's the hardware, software, screens, functions, outputs, and features that affect the two-way communication between the user and the computer. This can consist of, obviously, the forms, the screens, the GUIs, all based on the same thing. The output coming to these type of mechanisms, these forms and these GUIs, all the way to actual hard type reports, meaning paper reports that might actually go to the user also. This is the process of ensuring that all of this looks good, and once again, you're designing it out that your user says, this is exactly what I want. How does this help? Well, once again, usually what happens, based upon my experience, when I start putting these things together, these different prototypes and these different types of schematics around reports and so on, the user starts having more questions, saying, I might want this, I might want that, or I don't need this, and I don't need that. That really starts helping us narrow down the scope a little bit more on exactly what the finished product is going to look like. If we didn't design this, we just went from specifications, basically, the requirements, right to development. When we show them after all the development, they could look at this and say, that's not what I wanted, or where's this at, or where's that at? Next thing you know, we have just written a bunch of code for something they may not have needed, or we may have written code that is not giving them exactly what they want. Now we got to redo a bunch of stuff. Who pays for that? The user doesn't like repaying for things. So this design process allows us to sit back and make sure we paint these pictures. Doesn't take much time to do this kind of stuff. Matter of fact, very little time in today's world. When I said, with our technologies, we have to paint a picture very quickly with Visual Studio and so on to ensure that what they're thinking and what we're thinking coincide. That's what this is all about. A good design depends on 6 basic principles: the understanding of the business that we're actually working for, they maximize the graphical effectiveness. We talk about this in many of our classes, utilizing the controls on forms and so on that people are actually used to, from text boxes to drop downs to combo boxes to radio buttons, check boxes, buttons, and so on. You get the idea. We want to start thinking like a user. We can't think like a developer. We got to think about the person who's actually going to be using this system. We need to make sure that we're thinking like that. The term is, being empathetic toward the user, kind of getting in their mind. What would they want to see? How would they want to react to this page? We want to use models and prototypes. Like I said, building a storyboard is a great way of going through it. I have done things where I just start building screens out, again, using things like Illustrator or Visual Studio, and then taking them to my user to sit back and say, now, when you go here, you're going to click on this and do this. When you do this, it'll go to here. When you do this, it will go to here. The whole idea is a storyboard out. I don't put any code behind it because, once again, I want to make sure what I'm doing is correct. So I don't want to spend a lot of time coding anything until I know this is what they're looking for, user-wise, interface-wise. We want to focus on usability. Hell, there's a whole courses out there on human-computer interaction that talks about how a human looks at a computer screen and how they anticipate interacting with that computer screen. With that said, we don't offer those courses right now in our curriculum, but there is a whole courses out there, and there's a whole psychology out there. We want to make sure we're building an interface that promotes interaction with its users. Also, whatever we do, we want to welcome the feedback and we want to adjust during this phase. It's very important. Tell us what you like. Tell us what you don't like. Have people, analyze it. If possible, have people who understand human-computer interaction analyze it. Make sure it's right. That's what you want to do. You want to welcome the feedback. You want to throw something out there, have people respond to it, modify it, throw it out again until finally everybody says, that's what I want. And again, this doesn't have to take a long piece of time at all. It can go very, very quickly. All right, the other piece of design phase is the data design. For people who have taken our database classes here at Cincinnati State, for the most part, we're starting now with the whole idea of design based upon the requirements. Well, where do those requirements come from? Well, I'm kind of hoping if you have taken that IT 111 already, or you're in the process of taking IT 111, it makes sense that you're seeing that it comes from the requirements, okay, of the requirements phase of the system development lifecycle. So based upon that, that's what we're going to be doing. So the goal of the data design includes determining how the data will be organized, stored, and managed. We're talking about in a database of some sort. Cincinnati State, we work with SQL Server, a little bit with MySQL, those type of databases. We're going to build them based upon the requirements that we actually had gathered. Very similar to what we did in IT 111. We'll go through and understand the requirements, and based upon those requirements, understand our entities, the relationships between the entities. We're going to design the relationship database based upon that design, and we're going to ensure that it's completely normalized. Once again, if you haven't taken IT 111, that's what you're going to be doing in it. If you have taken 111, I'm hoping by listening to this, you start realizing where those initial requirements come from. And again, from the requirements phase of the SDLC. In addition to the design, there's also time to consider how and where the data is going to be stored, the security needs of the data, etc. We need to make sure we understand, what's the term I'm looking for? The security of the data, how important it is, who can get to it, who should not see it, those types of things. Okay. Based upon that, we're going to start working with the architecture piece of this to ensure that the data is 100% secured all the way through. I hope that makes sense, okay? So you need to understand that as you kind of go through it. Okay, the system architecture, as I mentioned before. This task objective is to determine an overall architecture to implement the information system being developed or installed. So when we talk about the architecture, we're basically talking about the computers needed, the network needed, how it's going to be utilized, where we're going to implement this new system, what kind of, computer or server or so on are the system going to be put on. In a lot of cases, there's so much that goes into this piece. We don't talk about it much in our current curriculum, but this is where all the networking and everything else comes into play. Based upon what I have done and throughout my career, we have specialists who deal with this architecture. I give them the requirements based upon what my database is, the security needs of my database, the access needs I have to my database, what my application is going to be in regards to a web-based application or a Windows-based application, or so on. And then based upon that, we'll sit down and draw out a plan on how this thing needs to be implemented. It could be as simple as, just a server, a web server with everything on it, or it could be as complex as putting it behind several firewalls and making sure the security is there and only certain people can get to it. So in this case here, what we want to consider is the type of information system, the scalability. How is this thing going to grow? Is it going to grow like crazy, or is it going to be maintain what its certain size right now? How is it going to integrate with the web? Does it need to integrate with anything else outside of its platforms or its actual application in regards to the web? This whole piece about legacy systems, you might not know what those mean. Those are old systems to a company, systems that have been developed, I don't know, 10, 15, 20, 30, 40, 50 years ago, but they're still using them. And trust me, they're still out there. How can we integrate with those if our system needs to integrate with it? Our processing options, and again, our security issues actually go through it. This all plays into part of system architecture. If you go look at the book that we recommend you look at and you read and review, you'll see different types of scenarios when it comes to architecture that can be considered. All right, again, this design, kind of quickly going through it, is not overly complex. Again, I don't think any of this is overly complex, but at the conclusion of this phase, we have designed the interfaces between the user and the computer, a design on how the data will be stored for a new information system, and the hardware and network architecture to support the new system. That's what this thing's all about. Hopefully you kind of see the progression here. We have an idea, we got the requirements, and now we have it all designed out. The goal would be is you would review this whole design, especially the interfaces and so on with your users. Pretty much all of it. They're not going to understand the database as much if you start talking databases to your user, but in regards to the interfaces, and then pretty much giving them an idea of how that's going to be supported architecturally wise. It's something that you definitely want to review with all your users and your customers. You want them to agree with it, okay? But regardless of the architecture and so on, that interface piece is really the key to ensuring that what you're going to be developing next is exactly what they want. And we don't have to worry too much about, once we're done developing, showing them something that we're not aware of. It's always good to have your users follow along in the process of development. This way, in the end, there's no rework, or at least we minimize the amount of rework at the end. And I hope you understand that rework is money, and sometimes money comes out of our pocket, so we don't want that. All right, so that's the design phase in a nutshell. Not too difficult. The final phase is the development phase, and we'll tackle that next.